5 machine learning algorithms you should know. Let's walk through 5 of the most important machine learning algorithms using simple real-world examples. First, linear regression. Imagine you run a delivery company and want to predict how long a delivery will take based on distance. You collect past data, distance traveled and delivery time. Plot those points on a graph and you'll probably notice a trend. Longer distances usually take more time. Linear regression tries to draw the best fitting straight line through those points. The goal is to minimize the overall error between the predicted delivery times and the real ones. Once that line is learned, you can give the model a new distance, and it estimates how long the delivery might take. So linear regression is mainly used when you want to predict a continuous number. Next, logistic regression. Despite the name, this one is usually used for classification. Imagine a SaaS company wants to predict whether a user is likely to cancel their subscription. The output is not $37. It's likely to churn or likely to stay. Logistic regression calculates a probability between 0 and 1. Maybe a user has an 82% probability of canceling. If that crosses your chosen threshold, you classify that user as high risk. That makes logistic regression useful for things like churn prediction, fraud detection, spam filtering, or approval decisions. Next, decision trees. These are probably the easiest to visualize. Imagine a music app deciding which playlist to recommend. Does the user mostly listen to hip-hop? Yes. Do they usually prefer energetic songs? Yes. Are they listening late at night? No. Recommend the workout playlist. A decision tree works in the same way. It repeatedly splits the data using questions until it reaches a final prediction. That also makes decision trees useful when you need to explain why a model made a particular decision. Now, support vector machines or SVMs. Imagine you have data from 2 types of flowers. One species tends to have wider petals, the other tends to have longer petals. You want to draw a boundary separating the 2 groups. SVM doesn't just find any boundary. It tries to find the one with the largest possible gap between both groups. That gap is called the margin. The larger the margin, the more separation the model has between the 2 classes. And with something called the kernel trick, SVMs can also handle cases where the boundary is curved instead of a simple straight line. Finally, k-nearest neighbors or KNN. This one works almost entirely on similarity. Imagine a streaming service wants to classify a new movie. Instead of analyzing every movie in the database, it looks at the most similar movies nearby in feature space. Maybe the closest 5 movies are mostly science fiction. Then the new movie is probably science fiction too. KNN works the same way. A new data point comes in. The algorithm finds the closest K examples, then it looks at their labels and usually chooses the most common one. Simple. But there's a trade-off. KNN doesn't really build a compact model ahead of time. It has to compare new data against stored examples when making predictions, so it can become slow when the dataset gets very large. The easiest way to remember these 5 is: linear regression predicts a number. Logistic regression predicts a class using probability. Decision trees make decisions through questions. SVM finds the strongest boundary between groups. And KNN predicts based on the closest examples. Different algorithms, different ways of learning patterns from data.